So one thing I like about teaching linear algebra is that it starts in a place that everyone taking this class really should be familiar with, although maybe not quite at this level of generality. In your high school algebra classes, you learn about linear equations in two variables, and eventually, maybe in a precalc class, you move up to three. We're going to take this a step further and let our linear equations have an arbitrary but still finite number of variables in them. Now, since we could quickly run out of letters, right, we're going to have to set aside using x's and y's and z's and so forth, and instead rely on writing our equations the way I have here, where all the variables are x's and we just use subscripts to distinguish between them. So a system of linear equations is just a collection of individual linear equations. And notice here how using the subscripts, again, helps us out here, since it gives us a way not just to identify the individual variables within an equation, but also to tell which equation the coefficient belongs to. For example, if I refer to coefficient a sub 3, 6, right, you can tell right away that value is associated with the sixth variable in the third equation. Now, a solution of a system of linear equations is a set of numbers that makes every equation in the system true. Right? So the solution set is going to be the set of all possible equations. As you saw back in your high school classes, sometimes that's a single set of values. Sometimes it's infinitely many values, and sometimes there's no solution at all. We're going to continue to see that even as we look at these bigger cases. So if we fall back on our two variable case, you can get a visual idea of what we mean by the solution set. In the first case here, the graphs of the two equations cross at a single point, which would be the sole member of the solution set. And in the second case here, the two graphs overlap each other, so the solution set would be infinite, specifically the set of points that lie on that line. Now, notice how in the first case, I wrote the system two ways. Right? One using the x and y notation that you're surely used to, and the other using an index variable like we're going to be doing going forward. So hopefully this was just kind of a quick warm-up, right? Reintroducing some ideas that you've already seen and expanding them a little, right? Making them bigger in terms of the number of variables we're going to be working with. In the next lecture, we're going to talk about something called a matrix, which really is, in a lot of ways, the core object of interest. In linear algebra, and as you'll see, a matrix is really just a convenient way of organizing a set of values, set of numbers, right? Specifically, for the kind of things we're going to be talking about, those numbers are going to be the coefficients of a system of linear equations.